Hello everybody, welcome to another day of CS 202. We have only 5 lectures left including today's. So we have 2 more weeks of lectures and then we got the final exam. And actually that's one of the things that I wanted to talk about. So we have study week, that's a full week, and that's after Thanksgiving. That is going to be December 7th and December 9th. Or sorry, no, my bad. November 30th and November 2nd. Because the week of December 7th is actually when you have your exam. So those 2 days we can talk about stacks and queues for the most part, and then do a little bit of review as well. I'm not exactly sure when the test is. I assume that they're going to go with that scheduling like they always do, with like you have a specific time. But if not, then we'll coordinate, because we can always just do it at the 2 time we had like the test usually, which is like 1 p.m. But anyways, in addition to that, we have Monday and Wednesday of next week. Wednesday being the 25th, Thanksgiving is on Thursday. So I'm not sure if we're going to have class that day. Because while we could have I'm not going anywhere. Some people might, because they might be watching the lectures on Tuesday, Thursdays, like on YouTube. They might not want to watch it during Thanksgiving. So I guess we'll, that is pending to see if we have a lecture that day or not. And if we don't, I can always pre-record something. But it really depends on how far we get. Because if we get done with linked list between today and next class, which I think we will, then we don't really need to have that day of class. Are we going to have an assignment during study week? So here's the deal with the current deal with the assignments. So you have 2 assignments left, I believe. You have a linked list assignment, and then you have some form of final project. The linked list assignment, I'm going to assume you're going to get at some point over the weekend. And then after that, you're going to get also the final project. Now, the final project is not, they're still elaborating it because there's 2 people that are elaborating it, and they suggested some ideas. It doesn't seem to be too bad. It seems to be a little bit like the creepy assignment, if you looked at that, which is basically like some sort of 3D array of data kind of thing. However, it's still being developed. As for deadlines, my guess is that both the final project and that last linked list assignment are probably going to be due around study week, approximately, if I was to guess. There's no reason. I could always make it due before, but there's no real need. I think if it's done, if we have one due like at the beginning of study week and the other one at the end of study week, then I think TA has enough time to grade them, but we'll see. But yeah, they haven't posted a linked list assignment yet, but I know that we're supposed to have one. So anyways, that's the assignment side. But that's the plan. So we have class today on the 18th, then we have class on the 23rd, and then 25th is kind of pending, depending on how far we get. And then we have the 30th and the 2nd to talk about stacks and queues. Yes, it's incorporated. It's worth approximately, I think, it'll be worth about anywhere from 5 to 10% of the homework points that we have so far. So far we got 2,000 homework points, right? So the final project will be worth anywhere from 250 to like 450 homework points. So it almost looks like another assignment in a way, approximately. And then the linked list assignment, I have no idea because I haven't seen it yet. But it'll probably be worth around the same, 200 points or something. In addition to that, the last thing I want to say before we get going is, starting probably next week, maybe next Wednesday, I'm going to lower the points on the extra credit redemption from the 10,000 points to like smaller tiers, maybe like 3,000 points tiers, and then I'll do like 1,000 point tiers, so that if you are like at 5,000 points and there's just no way you're gonna get to 10,000, you can still redeem your points. However, I'd still rather you guys redeem the 10,000 points if you think you're gonna get there, because that's just one redemption that I have to deal with, versus like redeeming 10 1,000 point redemptions or something like that. So I'll warn you guys about that. Other than that, then you guys just took the test. It's great. We're pretty much at the end stretch of this class. At this point, if anybody has major problems with something, they can take an incomplete and then finish the class at a later time. So like if like your house explodes on Thanksgiving or something, then that's an option, I suppose. So that's a good thing, because so far it does not seem like they want to do the SU system. But I think most people are doing good from the last time I checked the grades. So, okay, that's all of the sort of prep stuff that I wanted to talk about before going into the lecture. And if you're not watching live, still the information is relevant to you. So, like I said, today we were talking about linked lists, but we are going to focus on deleting, which we haven't really finished talking about. And then maybe a little bit about sorted linked list. And finally, we're going to talk about double linked list. But before I do those, I do want to bring up something that showed up on the exam. And if you got any doubly linked list questions on the exam, don't worry about it. You will not be deducted for that. It's like you got a free question for that. So consider yourself lucky. But there was something else that showed up on the test, which I didn't explicitly talk about. So, we might still give you the points on this. But maybe you got to write anyways. It's just kind of one of those things that if you think about it, it makes sense. But we didn't explicitly mention it. Or if I did, it was something I might have just mentioned in 5 seconds and moved on. And that's the idea of a circular linked list. So, raise your hand if you saw the word circular in your exam. Raise your hand doesn't, I guess, type. So does anybody remember what the question was, or what it kind of asked? If anybody got a question about it, it was like, what kind of linked list is circular or something? I don't remember. I know some people got it, but let's talk about what it means to have a circular linked list. It's not really much to it. So if we, refresher, I suppose, although, I mean, you guys got this down because it was in the test. Linked list is made up of two components, the data component and then the link component, and then it links to the next node of the linked list. And so here's the thing about this. You can make as many nodes as you want, and they can be sort of a chain, right? But guess what? You can also make this chain sort of wrap around. And while I could do some artistic thing here like I'm doing now, which is I'm trying to make this little circle, I can also just go ahead and add one more node and then just literally link it right there. And so if I link the last node back to the first node, I have created a cycle, right? Kind of a circle. And that's where the concept of a circular linked list comes from. It's not really used anywhere that I'm aware of. Maybe like a scheduling system, but not really. And then you still need to have a head pointer somewhere. But I guess at this point, it doesn't really matter where because it's a circle. So yes, this used to be the start of the linked list, but now it's just kind of part of it because if I start here, it doesn't matter. I'm still going to be able to get there in a circle, right? So the question asked, explain how to make a single linked list into a circular. Yeah, so all you got to do is take that last pointer of the node, take the last pointer of the last node, so the last node's pointer, I suppose, and then just link that to the beginning. So in a more traditional sort of representation of that, we got something like this, normal linked list. All I'm going to do is I'm going to update this pointer from null and set it to be the address of the first node, which is actually stored in the head pointer, right? So I just basically copy the head pointer into that item. So by replacing this with the head pointer, what that is essentially doing is linking it there, and you've created a circle basically. So that's what a circular linked list is, and whether it's a singly or double linked list doesn't actually matter. So I think that was another variation of the question. It doesn't matter because if you can go in circles, if you're trying to get to the one behind you, all you got to do is just go almost a full circle, right? So it doesn't really matter whether it's single or double. You can reach anywhere in the linked list as long as it's circular. But like I said, it has very, very small practical uses because ideally you want to have a beginning, very existential. You want to have a beginning and an end to everything, right? It kind of applies to linked list because if you don't have a beginning or an end and you're asked to print the contents of the linked list, you could be going on circles forever, printing the same thing over and over again. How are you going to know when you reach the end? The only way that you know that you reach the end of a linked list is because you hit a null pointer, unless you have some sort of size variable that tells you how many items are in the linked list. So that's the other thing. If you're going to have a circular linked list, you need to keep track of the size of it because otherwise you have no clue how big the list is or how many items are in the list, right? And also when you're inserting something, you have to figure out where to insert it because it's always going to go in between two things because it's always linked together. So anyways, that was just the thing about circular linked list if you saw it. Again, don't feel bad if you were confused because we didn't really talk about it in detail or at all. I don't even remember. But, you know, I guess I feel like you guys could have figured it out. But even if you didn't, you will probably get credit for that question. And I say probably because I don't remember all of them that mentioned it. But I think there was only 2 questions and those 2 will get credit. So, okay. So anyways, moving on from circular linked list, we can go back to basically coding our linked list. And again, today's goal is going to be really to talk about deleting, maybe searching. We haven't really done much searching on a linked list. And I guess refresher again on deallocate, which is kind of going into the delete. And then from there, once we finish all of that, then we can kind of go in and make a double linked list. Okay, so that's kind of the plan, not just for today, but actually for the next 2 days. And I think we'll be done with linked lists after that. And then from there, it'll just be stacks and queues. Okay, so what you're looking at here is code that we did before the exam, like 2 days before the exam, I suppose, or 1 class before the exam. And so what I want to do first is like remember what we did. I mean, we looked at it on the review day too, but 2 days is a long time. So let's see, it's templated. Okay, we have a node. It's just a single node. The data is actually not a pointer, so it's just data like that. And then we have the next pointer, which is linking to the next node. Okay, and then we have 4 inserts for the 4 scenarios that you can insert, which is empty list, insert something, and then with the not empty list, we have insert at the beginning, at the middle, or at the end. So that is our 4 scenarios. We also have a insert at function, which is kind of like our middle insert actually. That's what the middle insert is. Okay. Then we got a print function, which is prints the contents. Again, this is not a circular linked list, so we know when to stop, which is when we reach that null pointer. The example that I've been giving you a couple of days is road work example of the bridge being built, and it says road closed. That's your null pointer, so you don't fly off the bridge and crash your program, literally. So that's that, and then we sort of did the quick deallocate, which is kind of the same thing as the print function, but instead of printing, what you're doing is you're calling delete on each of the nodes. And the trick that, you know, a lot of people might think, okay, you know, one way to do this is simply to say this, say like delete head, and then head gets head next, and then just those 2 lines in the loop. And guess what? It'll actually compile and run in a lot of computers. However, it's wrong, and sometimes it will crash in some systems. Here's the reason why. You are deleting the node, and remember, when you delete something, delete is a misleading name, because what you're doing is you're deallocating the node, right? What that means is that you are essentially telling the computer that you no longer need this piece of memory, so you're returning the keys to the apartment that you're renting, but what you're returning is a copy, and you still know where the apartment is, and you can still go in there. However, you've given away ownership of that, which means that the operating system may lease it out to somebody else to use that memory space. And if now you have 2 people competing for the same memory space, bad things are going to happen. So, I mean, for starters, the OS will probably, you know, if somebody else is actually using it, which is unlikely, but they are, you'll crash. You know, you'll get some error trying to access other programs' memory. So anyways, that is what is known as a dangling pointer. And so here, when we're saying delete head, the node itself has been deallocated, but you still have access because the head pointer still points to it, which is why you're able to update to point to the next node that you've deleted. So if we sort of visualize that here, what I'm saying is we have a linked list like this. And, you know, I'm using head, but you can use cur as well. The reason, by the way, that I'm using head in that code, because remember, if you remember what I told you is, you know, practice what you preach or whatever I was saying, is that you don't want to mess with the head pointer. You always want to make a copy of it, like I'm doing on the print function, and then work with the copy, right? That's because you don't want to break the head pointer. You always want the pointer of the head to be pointing to the beginning. The exception that I'm doing here in the deallocation is because A, if I am calling it the destructor of this class, it means that I'm never going to use it again. So it means that it doesn't matter what head points to. And in fact, part of avoiding dangling pointers is to delete and then set to null a pointer to not be able to access things by accident, which would be the equivalent of you getting rid of all the copies of your old apartment, all the old keys and all the old phone books that have the address of your old apartment, so you don't accidentally go there. So that's essentially what you're doing when you're sending something to null. So in this case here, we are able to use head because we're never going to use it again, and because we do want it to make sure it doesn't point to the first node. In this case, it'll point to the last node. But again, after it gets deallocated and the destructor finishes running, it doesn't really matter. So that's why I'm using head there. But you never want to use head except for this special case. And if you could even not use it in that special case if you just want to make it a rule of thumb. But anyways, what I'm doing here is I am saying I want to delete each of these nodes. So what I have to do is I have to call delete on each of them individually. So delete, delete, delete. So what I'm doing here is, if I'm using a copy of head, is I can make that copy of head like this. And then I want to say delete cur, which will basically delete this. However, before I do that, I need to be able to find what this address is so that I can delete the next node. Now that address is located at cur next. So, you know, I could hard code it and say delete cur and delete cur next, but that's not really going to work when this linked list is undefined size. So what do? I just update my cur pointer or the head pointer if you're using that. However, if you do this, then you have lost access to the first node. So you need to delete it before you do that. So that's why, you know, it's easy but wrong to say, okay, first call delete so you can delete it, but you still have access because it's a dangling pointer, and then go ahead and call cur next. That will work, like I said, but the problem is that when you deleted cur like this, and then you're updating cur to be pointing now to the second one, which is this one, you're accessing still the old cur, which is accessing something that is no longer yours, which is the dangling pointer issue. So the solution to this, which is what I did in the original solution example that I show you there, is I actually make a temporary pointer. And then I basically copy the address of cur to that. So what I'm doing now visually is I have my cur and now I have my temp both pointing to the same location. Once I do that, then I can just go ahead and update cur. So now cur is going to be pointing to the next node, like such. And then temp is still pointing to the old node. Now I can just go ahead and call delete temp, which will indeed delete that first node, but I no longer have the issue of accessing something that's no longer mine because I updated the cur after I made a backup copy of it here. So that's why you need that extra pointer. So that's why these two lines of code, while they might work in your computer, they will crash others because you're accessing a dangling pointer, whereas this one is safe regardless. You are making a copy of temp, then you are updating the pointer, and then you're deleting the pointer copy. So there you go. That's where that came from. So this is the longer explanation of what we kind of rushed through. Okay, so we just have the implementation of all of that, and we have some test code. So this is cool, and now what I want to do with this is I want to create a delete, search and delete. How about that? So we're going to create a function that is going to search our linked list and is going to delete a number if found. In fact, maybe we split that into two tasks. The search and then the delete part. So maybe let's just write a function that can search a linked list for a given value. And if it is found, then it can return to us the index where it's at. Now, what does an index mean when we're talking about a linked list? I just mean, you know, the nth node. So like if it's the second node, then it's just going to return to me like an index of 1, right? Because arrays, we want to go with the whole counting from 0 thing. I mean, we could go with counting from 1 if you guys prefer. But, you know, if we want to be traditional, then the second node is technically the first index, right? Because 0th index. So, shall we begin? Hope you all have a good time taking the test, by the way. Okay, so, and then of course, once we finish that, then we'll do a delete using that index. We'll make a function that takes an index and then deletes that node. So we're going to call it search at. And that's actually going to be very similar to the insert at, now that I think about it. And then we're going to call the delete. Delete at. Now, I don't know if we need these parameters, actually. But I'm throwing it in. Actually, no, we probably don't need them. Not with the delete. We just really need an index for that one. And then search at or search for. No. What were we trying to do for that one? It was just search. Yeah, so search. So for that one, we're searching for something. That's going to be the data component. And that's really all we need. But that, how about we make it valid returning? So it returns the index in the return type. And then the delete takes that index. So then our function call to search and delete can be something like delete at, and then inside of that we call the search at function. So yeah, I think that'll work too. It'll be interesting because we always do these void functions, which are kind of boring. Okay, so these are templated functions, and I do hope that you all remember how to do templates in the exam. Which is you gotta put this. The other way to do it, which I never really use, but it does exist, is to do the type name T like that. There is technically a difference between the two of them, but it's something that is just, it's not something you have to worry about at this point. So you might as well just think about them the same with a grain of salt, as in like there is some tiny difference. Okay, yeah, that's it. So actually this one's not even templated technically. So I think it wouldn't compile if we don't put the templated part in it. Wait, what? Sorry, I was thinking about something else. It's like daydreaming in the middle of the lecture or something. Okay. So we got linked list, delete at, and int linked list search. I don't know why the colors are being like that. Ah, well, this needs data. Okay. Now the colors look okay. I mean, that's yellow or... You know, I can't figure that if this is white or yellow. It's like... I think it's white for this one, but yellow for this one. So maybe... Let's just try to compile. It's white. Are both of them white? You know, the reason why I can't figure out is because I had that nightlight setting on. So, like, everything looks yellow. So now I don't know when something is truly white. Like, this looks white, though. But to me, it's like yellow-white. But I still know it's white because it's yellow-white versus yellow-yellow. Okay. So, anyways, it compiled somehow. All right. So, I guess we do the search at first. Or do you want to do the search at first or the delete at first? I don't know. At some point it started to bother me during quarantine to have this bright white blue light on. And I turned it on and it sort of stopped bothering me. And so I was like, I guess I'll just leave it on forever. So, yeah. Okay. So, I forgot which one we wanted to do first. To delete at or the search at. Actually, it doesn't really matter. So pick which one you want to do first. You want to do the one that searches or the one that deletes? This is a search maybe first, I think. That might be more I mean, they both will work, but I think this will be more interesting. So this one's just really, remember what I said like in the beginning. If you know how to do the insert function in a linked list, you know how to do anything in the linked list because the insert function is like requires all of the skills necessary to do anything else. So like at that point, if you know that, the other ones are like tweaking it. And it turns out that when you're searching for something, it's the same thing as printing, which is the same thing as when you're traversing a linked list, which we did when we're doing an insert. So really all this is going to be is to have a loop. However, let's add a twist to it. Let's make it recursive. Let's make it recursive. I like that. Yeah, I don't know what did you say actually? Was it profanity? Does it have to be a linked list? Oh, is that what you said? Does it have to be a linked list T? I have no idea what that got censored, but yeah. That's the thing. I don't think it does. I don't think this one has to be linked list. So I'm actually curious to see what will happen. So let's try calling it and see what happens. Right now, nothing will happen, you know, but will it compile is the question. So it compiles. Now, let's try to remove it and see if it complains. So it doesn't complain. So to answer your question, oh wait. I'm not running the right code. I am running the review code that we were doing with the money. Didn't think about that. This one was called LL3. So this might not be compiled at all. So okay, it did not compile. So I guess you do need it then. And then oh, did it not save? Template class linked list used without a template parameter. Okay, so this complaint that I have it that I am using it without a template parameter, so it doesn't really want it. The T after the linked list. So why is that censorship? The little less than or greater than T thing. That's weird. Okay, this is doing strange things. Delete at int index. Okay, first of all, let's get rid of the int part so it doesn't get confused, and then search T. Line 48. Oh, yeah, there's, I don't know what that white thing is doing there. Thank you. But it's still giving me issues. I know that, yeah, that was that issue, but maybe it doesn't like this type name thing. Okay, let's just erase all this for a second. Maybe I'm mistyping linked list. You have written linked list, not linked list. Oh, yeah, you're right. You're right. Yes, thank you. So that's what we've been trying to say all along, too. Yes. Okay, so that takes care of that. And then I just need to put the template thing back in there, probably. Okay, so to answer your initial question, yes, you do need it because of this part, I suppose. And then I want to switch this back to type name just to make sure that that would also work, because it should, but I want to triple check. Okay. Yay. So thank you. The censorship screwed things up for when you guys were trying to explain it to me. So I got lost in that. But okay. See, I have in front of me here the chat because I'm looking at the stream footage, and then up there is the actual chat that's not censored. So it confuses me. So yeah, when you see me looking up, it's because I have a monitor up there with the chat. The uncensored version of the chat versus this one being censored. Okay, so now let's do the search. But again, we're going to do it recursive because it'll be more interesting that way. So because we are going to be doing it recursive, we are going to be needing one more parameter, and that is a no type pointer. Because remember when you're doing recursion, it's like you have amnesia. And that's because you don't remember, like, what iteration of the recursion this is, I suppose. And so, the cur pointer will keep track of that for us. So I am going to have to update that. Here. And I didn't have to make this recursive, but I think it's good practice. Like, I know that you guys took the test already, but, like, you are going to need more recursion when you get to Trio 2. So we're going to get as much practice as possible with recursion. So anytime we can throw it in, we're going to throw it in. Okay, so initially though, we're going to make this a default parameter of null. That way we don't have to like pass that in when we call search, when we are calling search here. So like if we're going to say ll1.search and we're searching for like 5, we don't want to have to pass this like head pointer and things like that. It'll be just annoying if we do that. So Yeah, we're not going to do that. And then for the default parameter, I think we might have to put it on the top to do that. Let's see. First, let me see what we got. I may not have default parameters. Oh, well, I know what it is. Actually, no, never mind. I thought it was going to be because the order of the parameters is wrong. But here, we have to get rid of the cur part from here. We'll see if it wants the default parameter. Okay, so we're going to put it up here and see if it okays it. And then let's try to get rid of it from here and see if it lets me do it. Yeah, okay. So, okay. So, again, why I'm doing this to null is because, actually, I don't need it to null. I can just make it the head initially. But let me compile like that. Let's just check. Because it's a private, so it's non-static. Yeah, okay. So then in this case, we'll make it null. Okay. So what I'm doing is I'm making it a default to null, the pointer. So whenever I don't call a specific spot of the list here, a specific node, all I'm doing is essentially passing in null. It's a little sort of hack / trick that you can do, because now we can say something like if cur is equal to null, then that means it must be the first time that I'm calling it, as long as I never call it on null. In which case, I can simply say cur is equal to the head. Equal, not equal. Okay? So that is going to always start our recursion on the beginning of the linked list. Now there's a catch to this. I can never, ever call this function with null again, because otherwise it's going to reset to the beginning of the list, and I suppose we're going to have a circular linked list. So I want to make sure that I never, ever do that, okay? So also, I need to keep count of, this is trickier than I thought. We need to keep count of how many nodes we've checked so far, because we have to add 1 to that. But the count for that is going to be kept tracking the return type. So, okay, so this will be interesting. So what we need to do is we need to return 1 plus the count of whatever next we have to search. I think that'll work. So for the search, it's always going to be the same data, but here we're going to want to pass cur next. However, we want to make sure that this is not equal to null, because if it's equal to null, then it's going to reset. So we're going to write this in the if statement saying if cur next is not equal to null, then go ahead and call the function. Alternatively, if it is equal to null, then we're just going to return 1 of that. Okay? Or 0. 1 or 0. Let's do 0, because we index 0. So I think that'll work better. Yeah. Okay. So alternatively, we don't want to go on and call again if we found what we're looking for. So we need to have an if statement that checks to see if what we're looking at, so if the current node, so if cur data is equal to what we're searching for in data. I know we use the same variable name, but don't get confused between cur data and data. Data is just a parameter that we're passing to what we're looking for, and cur data is actually the data component in the node. So if that's equal, then we found it. So at that point, what we want to do is we want to return that index. So in that case, we are going to return 0. I think 0, not 1. Because what's going to happen is this. Let me draw it out, because this is a little tricky. I did not expect this to be as tricky with the recursion, but hey, that's why we're practicing recursion. So what's going to happen is if we have a linked list like this. Okay, I think that's enough arrows. We'll fix that one. Every time this function gets called, it's going to look to see if what we're looking for is what we found. So let's talk about the first case scenario, which is like it's found as the first item, right? If it's found in the first item, we consider that to be index 0, right? So we want it to return 0. So that's okay. We're good there. Okay, suppose that it's not found there. You have two choices. If that's the end of the list, then you give up. Ooh, in which case maybe we need to return like a -1 in that case, because that might show us that we're not found. So we'll have to think about that in a second. But okay, pending to fix the situation where the item is not found, let's say that there are still nodes to search. So the next thing we're going to do is we're going to call the function again, but on the next node. So that's line 58. What we're doing with which you can't see apparently. Okay, now you can see it. So line 58. So nobody told me about that. Hopefully you guys see that before. So line 58 is what it's going to do is it's going to call search again, but this time it's going to call it on the second node. So we add 1 to indicate that now we are looking on the next index, which is index 1. And that is found at cur next. And then if we find it there, then what we do is you return 0 because when we get back to this line on the first call, we do 1 plus 0. However, if we have to go in again to the next node, then we move on to index 2. And so now suppose that it's found there. Okay, this returns 1, which then gets added to this one. So you get 2 out of that, which is exactly what we want. So that is why this line of code of adding 1 plus a search is going to work for us in the case that the item is found. Now, suppose that we run out of scenarios, which means that cur next is equal to null. This return 0 is the one that we got to modify, because that is going to be the only time this is going to get called is when something is not found. So ideally, I was thinking we could return -1, but that's not going to work because it would just return 1 minus the last index. So as a nasty hack, the only thing I can think of is we're making it return a really, really big negative number that is always smaller than the size of the list, because that means that we're still going to get a negative number out of this. That's the only thing I can think of as a current way of fixing this, without having a different function that measures the length of the linked list. So we'll go with that. Big negative number that is not overflowing though. Is this going to overflow? Too many zeros? No, negative 99 million. That's perfect for our usages. It does limit the fact that if we have something that is 1 billion nodes, it's going to break the search function, but you know, recursion has its limitations. So yeah. Okay. So let's see if all of this actually functions though. Let us try to search for something here. So we're going to see out found at and then the return of that, because remember it's a value returning function, so it's just going to return an integer. And it's only going to search for the first instance of something. Okay, so I don't remember what the ordering of the linked list is. So we have a 5, 8, 6, 3, 1, 2. That is coming from this print function here, the one on line 114. Maybe scoot this over just a little bit so you see the line numbers better. Like that. I try to keep it as small as possible so we have most space. So I guess that one's a nice little edge case of searching for something at the first index of our linked list, which is 0. And you can see it says found at 0. Okay, maybe let's try looking for the 8 to see if it returns to you the index of 1. Or actually, you know what? Let's make it interactive. So let's make it a little. Little for loop that runs forever on, you know, searching for items. So while, so let's say int input equal to 0, while input is not equal to negative, actually this is a car. Nah, we can use negative numbers. So we'll say -1. That's going to be our special key to quit this little loop. Okay. scene input, and then input. Okay, so yeah, so now what's gonna happen is, can line 115 be while input? Oh, no, this meant to be int. Okay, so now we can enter a number that is going to look for. So let's try 5. 5 is found. Let's try 8. 8 is found. Let's try 1. 4. Is that correct? Let's see. 0, 1, 2, 3, 4. Yep. Let's try something that's not found, such as 9. And as you can see, you get a really big negative number. It's not negative 1 billion because, again, it's subtracting from the length of the list. So that's kind of a sort of ghetto way of counting the length of the list too, because you just gotta subtract or add 9, you know, yeah, you can add basically 1 billion minus 1, and then multiply it times negative 1, and you get the length of the list. So, but yeah, let's try 2. That's the other edge case. That works out. Let's try something weird and see if it crashes, like an X. Yeah, that just kills it. So, okay, but yeah, so there you go. So our search function is working as expected. So, yeah, cool. Well, here, let's try to see if the closing works. Negative 1. Yep, negative 1 does work for closing it. And it's interesting because it's actually looking for negative 1 in our linked list. So, yeah, interesting. Okay, anyways, it was just some kind of quick impromptu input. So, okay. So that shows us that the search function works fine. So now let's make our delete function so that we can then combine them to have a search and delete sort of thing. Because the end game is we want to not just be able to search, but we want to be able to say something like this. Actually, well, let's leave that. And then we can say LL1 delete at search, or sorry, LL1 search, and then the input, because that's going to search and destroy per se. And after we do that, we probably want to call the print function again so we can see it with a line feed before and after, so it's like nicely separated. So yeah, okay. So that's going to be sort of the, we already have a delete at function. Or did I add that later? Oh no, I did add that later, okay. I was gonna say like, where did this come from? But okay. Can line 115 be while input search and destroy? Yeah, search and destroy. I do like the term search and destroy because it sounds cool. Go to this. Okay. So right now, it's not going to delete anything, but if we were to type something like 6, it would say us found at 2, and then it's going to reprint it, but by then it should be deleted. So we will see if that actually works, okay? So we could also do the delete recursive, by the way. Shall we do it recursive or shall we do it iteratively? Your guys' choice. If we do it recursive, though, I am going to have to add one more parameter, just like I did here. But it doesn't matter. Easy either way. Iteratively. Okay, we'll do it iteratively. We can always later on go back and do it recursively too. So this one's easy then. First of all, we are going to make a temporary pointer called cur, as usual. We're going to copy the head to it. That is basically going to be where we're going to manipulate. And for this one, actually, a for loop is better than a while loop, because our for loop can be something like int I equals to 0, and then we can say I is less than index, because remember, index is the spot we want to delete. So if we want to delete the second spot, then this would run 0, 1, and then would stop. It would not go to the 2 because the 2 is not less than 2. So that is kind of what we're looking for here. Okay. In fact, actually, if we want it to hit 0, no, it'll be good like this, because we don't when we get to what we want to delete, we don't want to be getting just a pointer to where we delete, right? Because this is going back to sort of a scenario that happens when we're deleting, which is if I want to delete a specific node, let's put 4 of these in here so you can see it. So suppose that what I want to delete is this node here, okay? If all I am given is a node pointing to that node, I can't do the delete successfully because I need to be able to update this pointer to make sure that it points to this node, okay? So what I really want out of this for loop is I want it to actually point to the node before it. Because then I can use cur next to basically get this pointer, which then I can go ahead and delete this as needed. But also I can use cur next before I do the actual delete to get different color to get this pointer so that I can link them correctly. Okay, so that's why I ideally want to get the pointer to the node before the one I want to delete. So I think if I leave it as I have it now, I will do that, because if I'm deleting the third node, which is what I'm doing here, because think about indexes like 0, 1, 2, 3. So if I'm trying to delete, I suppose the third node, which is index 2, if the index 2 is here, this loop is going to run for 0 and for 1, which means from 0, it's going to get me to 1, and then actually in that case maybe I want it to be I is less than I might want to do I minus 1. Trying to think if that would be okay. The only weird scenario here is if I'm trying to delete the first node, because the first node doesn't have a node before it. So how about that? We'll do a special if case for that. And that way we can deal with that. So we can say if index is equal to 0, this will be our special case. Deleting first node, because there's no node before that. So otherwise, this doesn't work for that scenario. But for any other case where we're not dealing with the first node, then we wanted to basically get out the one before it. So if it was index 1, for example, then we still don't really want it to run a single time. So yeah, so we'll do I is less than index minus 1. So like if index was 1, then this would not run at all, this for loop. We would get back to first node. But if it's index 2, it'll run one time to update it from 0 to 1. So okay, so we'll use this like that. That'll work. Okay. Let's deal with the special case first. So the special case is easy to delete because all we really have to do is we already have cur pointing to the temporary node that we want to delete. So all we really need to do is update the head pointer to say cur next, and then we can go ahead and say delete cur, and pretty much call it a day on that one. We updated the head pointer and we call delete on the node. Done. Okay, so for this one, what we want to do in here is we want to just simply say cur gets cur next. And maybe to be extra safe, because I mean, I'm expecting to get a valid index, but suppose that I was mischievous and I give it an index that was out of bounds. To avoid sec faults, I can always do something like if cur is not equal to null, like that. And if it is, then see out error or something, just to avoid potentially giving it an invalid index. Because like, again, I'm assuming that the index is inside, but let's say I give it index 4 in this. There's no index 4 in this. If I don't do that if statement, I'm going to hit a null pointer and crash. Now I'm still going to be in trouble, but at least I'm not going to crash. I'm going to get this nice little message that says error exclamation point without any sort of context, detail, or information to the user other than there is an error. So I'm not sure what's better, but at least it didn't crash. Okay, so that's all the loop is doing. The loop is taking us to the spot that it has to take us. It is indeed the best error. Or the one that says an error has occurred while generating an error message or something. So that's scary. Okay, so now that we know at this point our cur is pointing to the node before. So as I have it on the picture there. So now what I want to do here is I want to be careful how I do this. I'm going to need another temporary pointer for this, actually, probably, so that I don't have a dangling pointer issue. I'm going to go ahead and make that temporary pointer be the node that I want to delete, which is cur next. Okay. Then now that I've done that, I'm going to update the cur next pointer with the node after the next one. So that's the next part, like that. Yep, and then that will pretty much take care of linking into the node after it. Now, there is an issue here that I'm looking at. If cur next happened to be null, this will segfault. Yes, so that will segfault. So imagine a scenario where I'm deleting 3. Cur next is null, so that's okay. Actually, not so okay if we call delete on temp, because what I was going to do last here is call delete temp. So not very okay there. But updating cur next, which is a null pointer, with cur next, which is null's next, is going to segfault. So I need to have another special case here that says something like, if I am deleting the last node, then I need to be a little careful about this. Because now all I want to do is I want to say delete cur next, which is the last node. And then I want to set cur next to be null to move the road sign further back, because I guess we're rebuilding the bridge. However, the way that I find out if I am deleting the last node is I can check if cur next. Oh, okay, this might be an issue. Hold on a second. No, this can never happen actually, because if the index that we're deleting again. Actually, this can't happen, but it's again if we get an invalid index. If we get index 3 out of this, none of this is problematic. There's no problems here. The problem is if we get index 4 when there's only up to index 3. So actually, we don't need any of this. We just need to make sure that they're not doing bad things. So we can say if cur next is equal to null, we're going to yet again just say cout error 2 this time. Okay? Yeah, because that means that the index is wrong again. Invalid index again. Okay? It's almost okay, but it's still invalid. So we'll say it's error and then return out of that. And also, I forgot to put we want to return after that. Okay? So Windows XP old error message, task failed successfully. Yeah, I do remember actually getting that at some point. So, okay. So I know that was a lot of talking for just, but it's always a good thing to think about the edge cases because of weird errors coming up. And in here, all of the edge cases are when the index is invalid. If the index is valid, we literally don't need any of this except for like, we can get rid of this, we can get rid of all of this, we can get rid of all of this. All we need is like this line of code inside a for loop, and then these 3 lines of code outside of the for loop. But everything else in there is error checking, which is always a good thing, just because it makes debugging easier. So let's see if we compile. Oh, I forgot the I++ part in the for loop. Okay. All right, so now let's see if it works. So let's try deleting something in the middle. So we're gonna delete the 6. The 6 is going to return index 2, 012, and then it's going to hopefully delete that. Well, it found it. However, it didn't delete it. So that failed. Did it delete anything? I don't think so. Did we still leave the delete call? Delete at. Yeah, we did. So what went wrong with our delete? We are passing in the index. Yes, we are. And then if index is equal to 0, cur. If cur next is equal to null, error. Temp gets cur next. And then cur next gets cur next next. Then delete temp. I don't know. Let's just try printing it again. Let's try maybe deleting something that's not. Oh, ooh, that's the other thing. Because if we don't find something, it's going to try to delete -1. Then we should get an error there because it goes out of bounds. But we can see that the 8 is gone. Okay, weird things are happening. Let's see what happens here. Hold on. So first things first. The way we have the delete code right now, it's going to if the search returns a negative number, that is going to try to delete the negative number, which is out of bounds, which hopefully gives us just the error message. But I think there's more bad things going on at hand here. Let's see. Let's run it again. This time, let's just try to delete something that's not found. It's still deleting something. Okay, so that is the first sign of an error. It's just gonna go all the way into corresponding to the last item of the node. Okay, we can fix that. Let's just add an if statement at the top that says if index is less than 0, it's an invalid index. So we're gonna just say cout invalid index, and then exit the function. So that'll take care of not finding anything to delete. So now we feed it something that's not found. It's an invalid index. Okay, so that's okay. So now we're not getting random deletes happening. But now the question is, if we search for something like 2, and then search for anything, it doesn't delete anything. So it's not deleting stuff from that. Why is it not deleting? It's going all the way to the index. And then cur next. Cur next gets cur next next. Delete temp. I'm not sure as to why. Okay, so I guess what we can do is we can use a debugger. Let's use a debugger for this. Let me compile it again with the debugger flag and then do gdb./a.out. And then let's set up a breakpoint at line. Where does this function start? Line 43. Or actually line 47. Let's break on line 47. And then hit run. And then let's go ahead and type trying to see. Let's say we want to delete the 8. Okay, so let me hide this so you can see the debugging process because it's useful for you to see that. Okay, so now that I set up a breakpoint, I am going to use the step key to see each line of code run. So we're hitting the index, the if statement. Index is equal to 1, which is what it should be because we're trying to delete the 8. So 1 is not equal to 0, so it does not go into the if statement. Now it's going into the for loop. It's hitting the if cur next is equal to null, which should not enter that. So it skips that. Perfect. It skips that if statement. So now it is going all the way to temp. So, okay, so basically it only ran the for loop once. That's perfectly fine. And now we are looking at the temp gets cur next line. So that's okay. We're gonna set temp to that. And then we are setting cur next to be equal to cur next next, which is pointing to the third item in the linked list. Yes. Then we are deleting temp. Yes. Then the function finishes. Then we're calling print. And then the print function is running. It's printing the 5. It's printing the 6. Oh wait, it's printing the 6. So did it actually delete the 8? Yeah, it must have deleted the 8 because it's not printing the 8. So let's quit the debugger. So if I go ahead and type in 8, it does delete it. So maybe I was thinking this wrong. Maybe I was typing the index instead of typing the value to delete before. But it is working, or at least it worked in that case. Let's try to delete the 2. Okay, so the 2 doesn't work. That's fine. Let's try to delete the 5. The 5 works, but it replaced it with some garbage value. Okay. We can work with that. Let's try to delete the 3. That worked. So the middle ones work. It's the ending ones that don't work, and yet it worked now. So sometimes it's working, sometimes it's not. Okay, so let's see what happened actually with the deleting of the first value. So I deleted the 5 and it replaced it with garbage. Let's see where that case is. So that is coming from here. Head gets cur next, delete cur. You know, it could be an issue with the print function, but I doubt it. I think the issue might be here, but cur gets head, cur gets next, delete cur, head already is pointing to the next item, so there's nothing wrong with that. Oh, I know what happened here. We need to return after this. We need to return after this because otherwise it's going to try to delete 2 things at once, which is why we get garbage. Okay, so that'll take care of that scenario. So that takes care of deleting the 5. Yep, now we can delete the first item without problems, and we can still delete things in the middle. And stuff is now deleting at the end actually too. So maybe we fixed everything now. Let's see it. Now, I just want to make sure it deletes the last item. So the 2 gets deleted. No, so the 2 does not get deleted at the beginning. It breaks with the 2. Yeah, it breaks with the 2. It's not deleting the 2. It's not deleting the 2. It's not deleting the 1 now. See, it broke entirely now. Alright, let's start deleting the 3. Okay, the whole thing broke now. Why did it break now? If index is equal to 0, delete cur, return. Okay, let's try running it one more time. So let's try deleting the 5. The 5 deletes. 6 deletes. The 1 does not delete. It is. Okay, let's try to see if we can find a defined system that's not working and we can run debugger on that. So I think if we run it and we immediately when we run it, we try to delete the 2, it does not work. Okay, so let's try to run that version of the debugger. So gdb a.out. Okay, and then set up the breakpoint at line 47. Run the program and then hit the 2 so we see if it deletes the 2. Okay, so let's see what happens in this one. So we start at line 47, as you can see here. This is the line number and this is the code in that line. And then you step to run the next line. So it's hitting the if statement to see if index is equal to 0, which is not. Index is equal to 5. Is that the right index? Let's see. 0, 1, 2, 3, 4, 5. So the index is okay. We know that the index is being passed correctly. Therefore, it does not go into the if statement. It goes into the for loop. It's saying if cur is not equal to null, cur next, yes. Oh, that's the problem. Okay. Ooh, yeah. So, okay, before, see if anybody catches it. So it should not have hit this return statement, but it did. So do you guys see what the problem is? What I missed that, you know, happened probably because we're coding quickly and kind of dirty. Yes, no curly brackets. That is the problem indeed. So I added this return statement to avoid an issue, you know, with the error, but I don't have the curly brackets, so it's always calling the return. So this for loop is always running and is always just returning immediately. So yeah, that's major oof right there. So yeah. So now when we add those, at least we will fix that problem. I'm not guaranteeing that the whole thing will be fixed, but at least that will be fixed. So that's why debugger is good, because like something so obvious, but we don't see it. But when we see the debugger run a line that we're not expecting it to run, then we look at that and we're like, oh, okay. So anyways, let's try to delete the 2 now. The 2 does get deleted indeed. Let's try to delete the 1. 1 gets deleted, 3, 6, 8, 5. And then what happens now? Sec fault. Okay, so we can fix that later. No worries about that. But, okay. So let's try to delete the first item of the list. The 5, the 8, the 6, the 3, 1, 2. So that works okay too. Sec fault, sure. And then let's try to delete stuff in the middle. So like the 8, sure. The 6, yes. The 3, maybe the 1, 2, 5. Okay. So yeah, all the deleting is working fine. We just have this little sec fault happening. So I think I know what it is, like why it's happening, but let's just let the debugger tell us instead of trying to guess. So we can do GDB. This time we don't need to add any breakpoints. We can just run it. So let's just delete everything. 5, 8, 6, 3. I think I put an 8 and they just deleted what? Oh, there was an 8 already. Okay, that was. And then 1. And then just delete something, sec fault. So the sec fault is at line 80. So it's actually in the search. So the problem being that when head is equal to null, then it means it's an empty list. So if head equal to null, you know, this is basically, oops, what just happened? Okay, there we go. It's an empty list. So if it's an empty list, then whatever we're trying to find is not going to be found. So, you know, empty list, and then just return out of this. But we need to return something. So let's just say that when it's not found, it returns a -1. So it returns a -1 index. That way, the search will also say invalid index, and it will just give us a bunch of warnings, but it will not crash. Okay, so 2, 1, 3, 6, 8. Or I guess that's at 5, 8, and now we type something else. That's okay. We just get a warning that says empty list, MD1, empty list, invalid index, and no matter how many times we do it, it doesn't crash. And we can still quit out. So there we go. We fixed it. So I think that this was actually nice that we have, even though we did spend like 10 minutes trying to fix this, that was good because you got to see an example of using a debugger and doing what is known as breakpoints. So what I did is I set up a breakpoint. So when I ran the program in the debugger like this, with the GDB part, I type in R to run the program. If this program required command line arguments, I would type those in here like this, just like if I was doing on the normal terminal, like a.out 35. Let's say those were the command line arguments. In this case, what I do is you say R35. But in this case, there are no command line arguments, so I just put in R. However, if I do that, it just runs the program, and then I can just, you know, work with the program. However, and this is me just like typing Q and breaking it because it expects a number. However, if you want to set breakpoints like I did, what you do is when you run GDB, before you hit run, you can press B and then put a line number. And that line number is the breakpoint. So like if I want to set a breakpoint in line, I don't know, let's say, it has to be a line that's actually going to hit. Otherwise, you won't see it. But let's do something in main. Let's do line 138 because that's in main. If I want to put a breakpoint there, I just type in line 138. This is available to us because I'm doing the -G flag. You got to put that in when you compile the program. Otherwise, this doesn't really work, or it doesn't work as good. you'll see a confirmation saying breakpoint 1. I can put in multiple breakpoints, by the way. So if I want to put another breakpoint on like line 142, I can say B142 like that. Then when you're finally ready to run, you hit R, and when it hits the breakpoint, it pauses the execution. Not only that, if there are any parameters to wherever function you're at, it shows them to you. In this case, the main function has ARGV and ARGC. You can see ARGC is 1 because there's no extra arguments, it's just the name of the program. And then this will be the memory location of actually ARGV. So if I use the step key, it goes line by line in the code and shows you. So, you can basically see what code is running every single time. This is good because you have a mental expectation of what order things are going in. If they're not going in the order that you expect, such as what happened there with the else tape and then going immediately to the return, that'll be like, okay, wait a second. I was not expecting this line of code to run, but it did. So you can look and see as to the why that happened, and that will like 100% tell you what is wrong with the program, like pretty much every single time. The last thing I don't really remember is how to jump to the next breakpoint. I think it's C for continue. Yeah. So if you have multiple breakpoints and you just want to fast forward to the next breakpoint hits because you don't want to see other redundant code, you press C to continue and it'll go to the next breakpoint. You hit C again, then this is going to finish running because there's no other breakpoints that it hits. Until, of course, I type in something where it would hit a breakpoint. But it's expecting integers. I need to put some if statement checking to see if it's called sanitizing your input. Probably reading the car, convert it to a number if it's a number, otherwise giving you an error. But yeah. I've been using the built-in Visual Studio and it's been very helpful. Yes, all of the stuff that I'm showing you with the terminal base, you can do with an actual proper IDE, like Visual Studio or Eclipse or Code Blocks or NetBeans or whatever the Mac one's called, Xcode. There's so many IDEs and they all have the concepts of this. Like for example, this one, if you press here, that's actually a breakpoint. Except this is more like visual, so like it's nicer. But I don't have it set up in this one. I have it set up in the other virtual machine to debug using this one. So yes, if you just hate the terminal debugging, which can be a little bit painful to do, you can install a debugger and use an IDE, and it's just a little square here and shows you the contents of all your variables, which is very useful. It's called Variable Watch. It's very useful to be able to track if the data that you expect in certain variables is there. Like if you're expecting a counter to go like 1, 2, 3, 4, 5, and you're looking at it, it goes like 1, 2, 3, negative 10. You're like, what? So then that will give you a warning as to what's wrong. So anyways, that's the delete. That's kind of what I wanted to achieve today. At this point, I've shown you pretty much how to do anything in the linked list. The only thing you haven't seen technically yet is a sorted linked list, which is just a variation of this. If you're interested in seeing code for that, you can watch the summer lectures for that. Last time I focused on that. This time around, I focused on just making everything separate. But it would be very easy to convert this into a sorted linked list. You just basically use the search function to search where to insert. That's going to give you back an index, right? It's an integer. And then you use the insert app function and you put that index. So you can use that combined together to create a sorted linked list so that you're always inserting it at the right spot. So you have all the tools available here. That way, it's not always just the same every single time. What we still got to do is a double linked list. I mean, when I do that, I can make a sorted double linked list. But I will go ahead and save that until next class, since that is the last thing that we need to talk about linked list. A double linked list is just the same as a linked list, but there's 2 pointers instead of 1. Allows you to go in 2 directions instead of 1, forwards and backwards, which can be beneficial for scenarios where you're just pointing to a node and you want to go to the one before it. You have no way of doing that. If it's a circular one, you can wrap around, but if you don't, you have no way of doing that. So double linked list allows you to move in both directions, which is kind of useful. Not necessary. You can achieve the same things you can with a single linked list, but it's just convenience at the end of the day. So that'll be the next class lecture, and then we'll be done with linked lists. So expect that assignment to come up at some point in the next few days, probably before the weekend hits, but I'll keep you updated. But yeah, if we finish double linked list, like I said, we probably don't need to have a lecture on the Wednesday before Thanksgiving. We'll see. Stay updated on that. But yeah, so that is the end of what I have for today. So hope you all have a good weekend. Do you have any extra credit that goes to our exam points? No, but you know what? You brought up a really good point. So I have made a Discord survey available. That's homework points, but it's at the end of the day that helps you for your grade overall, including the exam. If you have over 100% in the homework, then it helps other areas. So there's I said Discord survey. It's not a Discord survey. It's a survey about live streaming that I'm doing for a mini report about whether webcams and live streams are better or not than pre-recorded lectures. So, which I am doing for the 301 class that I'm doing this semester. So, it takes about 15 minutes. If you want to do it, you will get 50 homework points extra credit. You only have about 4 days to do it, I think. I don't remember when I set the deadline. So just go ahead and do it. Don't discuss it because I don't want to bias people. I'd rather have their opinion before anybody else kind of changes it. So go ahead and take that. But that's the only extra credit that's available right now. I don't think any more extra credits will come out at this point since we've had multiple homework assignments as extra credit. So yes, we're sort of at the end of this. But yeah, that's it. The SU grading. That's a massive link. I don't think, well, I mean, I guess people could try to copy it by hand. But yeah, there's a petition. I posted on Discord that I actually did public comment at the Board of Regents meeting requesting SU grading. And unfortunately, you can check the Discord, you can check some videos that I have unlisted on their response to that. It said they approved that? Oh, did they? Did they change their minds? Let me try opening it. You know, that Board of Regents, they seem very against it, so... Did they really do it? Let me see. Because if that's the case, I might as well announce it while the lecture's happening. Substance abuse email, but I don't know. That would be really cool if they did. Well, this is a town hall, but the question is... I don't think you can hear this in the video. Let's see. Oh, so this is a so this is a town hall meeting. Okay, so this is not the Board of Regents meeting. So the Board of Regents meeting was on Friday of last Friday. This happened more recently than that. I'm watching the video. Okay, so it seems like yeah, I mean you guys did it. Congratulations, but I would not call it victory yet because he did say a limited number, so you have to be very careful about what the tiny footprint on the contract says. So I would not call this a complete victory until we see the full terms and conditions of this. But that's pretty cool. So hey, never mind. I guess the public comment did work. I was pretty disappointed about the Board of Regents meeting last week, but yeah, it worked. That's good job on all of you. Good job everybody that spoke. It was like I watched it. It was like I actually, even though I really strongly supported the SU thing, I kind of did get annoyed after like 20 minutes of hearing it because I was kind of anxious to see what they were responding. I'm like, okay, any minute now they're gonna finish to them so we can hear back their feedback. And I got pretty impatient, but I did listen to it all, and it was pretty cool, very passionate. So that was really great. And then they got really angry when they finally responded, but. It does seem like UNLV. This seems more like a UNLV thing versus like the full NG like UNR and everything. So yeah, very good. But be careful. Like I said, I will definitely monitor this and make an announcement on that. If there's if it's like a thing where like they're like, oh, the instructor has to approve it, then yes, of course I will approve it. But we want to make sure that there's no tiny footprint that says, oh, this is only applying for like, I don't know, in-person classes only, or classes that happen on like Fridays only, or some weird, thing. So be wary, but it is definitely something to be proud of. Well done to everybody who was active about that. As you see, there is power in numbers, and there is power in making your voice heard. So definitely continue to do that, not just for this, but for anything that you feel should change, and not just the university, but anything. So well done to everybody. That's good news. Thank you for telling me that. I'm probably gonna go research it now and see what the details are. But well done. All right then. So good news. I guess we can end it on that happy note. So I'll definitely read up and let you guys know how this applies to us. But fingers crossed, I mean, hopefully none of you need it. Hopefully none of you need it. But if you do, this is a great resource. So have a good weekend, everybody. Take care and well done, everybody. I'm proud.